Hi, good morning, everyone. Thank you for tuning in to Steam Trivia Live. My name is Samantha. You can call me Sam. And while I'm talking, please go ahead and ask questions in the comments, and I'll try my very best to answer them. Okay, so today we'll be introducing you to cell and tissue culture and its applications within the field of biotechnology. But before we delve into this week's topic, let's talk about why we're learning science in the first place. What is STEAM and why is it so important? Okay, so STEAM stands for science, technology, engineering, and art. Oh, and mathematics. So that makes up STEAM. And these subjects are important because they pervade every part of our lives and they allow us to comprehend, allow us to understand the world more fully. So, for example, science is everywhere in the world around us, like how right now the light from your screen is being reflected into your eyes and allows you to see me through this live stream right now. Maths is very important. It's in every occupation and every activity we do in our lives, whether we realize it or not. And technology is continuously expanding into every aspect of our lives. And can you imagine how different our life would be without our smartphone, without the internet, or indoor plumbing? Engineering is all about the applications of science and maths. So engineers are always thinking of ways of how they can apply science and maths concepts to solve problems. So engineers improve people's lives and they make something better by applying science and maths concepts. So then comes the A. So the A in STEAM stands for art, and usually we think of art as separate from STEM, but really in practice, science and engineering and technology are all deeply creative fields. Um, so, for example, when an engineer is developing a new product or a software developer is fixing a piece of code, they're making it shorter, they're making it more readable, what they're actually doing is that they're solving problems, right? And to solve problems, you need creativity in order to come up with new innovative solutions to progress. And STEM is an intrinsically creative field. Even though maybe now, from a student's perspective, maybe you cannot see that yet because maybe science and bio is just about memorizing things. But really, once you start applying all these concepts and techniques into the real world, you need to be creative. And that's why we include art and STEM, turning it into STEAM. Okay, so now that you know why learning STEM is important, let's delve right into tissue culture. Okay, so what is tissue culture? Tissue culture is actually the growth of tissues or cells in an artificial medium, separate from the parent organism. But let's break down this definition a bit more. So, what does artificial mean? So, artificial actually means false or not natural. So, tissue culture is actually taking out tissues and cells from, let's say, the human body, the parent organism in this case, and putting it into like a petri dish filled with a nutrient solution. So, the nutrient solution in this case is the artificial medium, and scientists have to figure out what combination of solution will be best for this particular group of cells. Both tissue culture and cell culture actually have the same definition, but the difference is cell culture explicitly refers to the growth of cells in an artificial medium, whereas tissue culture can refer to both tissue or cells grown in an artificial medium outside the parent organism. Okay. So now, if you were to Google tissue culture right now, you will come across lots of articles about propagating plants, about cloning plants. And a very common application of tissue culture is cloning desirable and endangered species of plants, such as orchids or pitcher plants. For example, like an orchid with very beautiful flowers, and someone wants to clone the exact same orchid because it has a very special pattern on the petals, for example, and so they want the exact same species of orchid. So they tissue culture that orchid and make like 10 or 20 and sell it in the market, or Another in more industrial application would be cloning of certain species of fruit trees that are highly resistant to disease. So a farmer could tissue culture this particular banana tree that the monkeys don't want to eat, that the locusts don't want to eat. A banana tree that's highly resistant to disease can also be tissue cultured and propagated. Um, but more recently, tissue culture applications have been more experimental. So experimental applications such as growing meat in a lab or bioprinting organs. So maybe the first time I heard about this, it didn't actually occur to me how incredible these applications are. So growing meat in a lab, for example, lab grown meat, or also known as cultured meat, is basically taking the basic units taking the basic units of life, that is cells, and sort of differentiating them and encouraging them to turn into meat tissue that we can eat without having to grow and breed an entire cow or chicken. We can actually grow just the meat or the animal products in a laboratory. Um, Bioprinting organs, the idea is very similar to 3D printing, but instead of using plastic filament to 3D print, we're using cells, a cell solution that will slowly differentiate, come together, turn into tissues, and become a fully functioning organ. And all these new technologies have incredible potential to improve the world that we live in. So now, oftentimes, a scientist will discover or develop a new technique and say, hey, it's possible to do this cool new thing, like grow meat from somatic cells. But the scientists need help to commercialize this technique, right? So that's where entrepreneurs will come in and they'll say, hey, this is amazing. There's definitely a problem that could be solved with this technology. There's a market for this. So all these business people, they develop this product together with the scientists. And these businesses then go on to hire more engineers, more scientists to help develop a product to solve the problem that they have identified. So, for example, in the case of lab grown meat, there's a huge market for it because there's lots of vegan or vegetarian people in the world, or people that are against like animal cruelty, and therefore there's a huge market for lab grown meat that's which is more environmentally friendly and more sustainable for the planet. So while we're talking about the end product, so we're talking about cultured meat, we're talking about printed organs, so that's a product. But before we talk about the product and the applications, let's look at the problem. So the problem now is that meat production has this huge environmental impact on the planet. Livestock, that is cows and pigs and chickens and goats, they're all bred for meat, and they all take up space. They all need food and water, and so as a result, they consume a lot of fresh water. They pollute our natural water sources for the excrement of the animals. They sort of flow into the rivers, they flow into the lakes, and they're also sometimes sprayed into the air. And all these animals, they also release greenhouse gases. And because these greenhouse gases, all of them together, actually, the livestock farming all over the world globally actually has releases more greenhouse gases than fossil fuels. So can you just imagine how many animals we need that release enough greenhouse gases to so there are enough animals in the world so that there's more they pollute the environment more than fossil fuels. So this is obviously not a sustainable situation, right? And scientists say that in order for us to sustain our diet, in order for there to be enough food in the world for everyone, we need to reduce our meat consumption by about 50%. We need to stop breeding cows, stop consuming animal products, so that we all can have a decent quality of life. But how likely is it for us to convince 50% of the global population to become vegan? or become vegetarian and stop eating meat or reduce their meat consumption, because it isn't easy. And if anything, it's going to take a lot of time. And we don't have time. So, what if instead of convincing people to stop eating meat, what if we just eliminated the need to breed and kill animals to get the meat and to get the animal products like leather? So what if we didn't even need animals in the first place? So we don't need all that space, we don't need all that water, we don't need all this extra grain to feed the animals. And we can achieve this by culturing meat and animal skin in labs using tissue culture techniques. So instead of growing an entire complex animal and feeding it and giving it water every day, what if we could use the basic units of life to grow the products that we needed? So the amazing part is that it's actually already possible to do this. But scientists are facing some major obstacles in terms of the costs and the technology limitations. So right now, it's actually really expensive and difficult to produce large quantities of cultured meat affordably. So it has to be affordable. It's not, oh, no one would buy it, right? No one would buy it if it costs 1,000 ringgit for 1 kilogram of chicken. So the challenge is to make it affordable and also to produce it in mass quantities. So because we need it in order to save the earth. So this is where people like biotechnologists or bioengineers, they come in and they think of ways to mass produce, to commercialize this technique. And without them, it will be just really difficult. So we need all sorts of people from all sorts of different fields. We need scientists, we need engineers, we need mathematicians, software developers to come together and solve this problem together. Okay, so another big problem that we're facing today is the lack of organ donors, particularly a lack of kidneys. So right now in Malaysia alone, there are 25,000 people on the organ donation waiting list, and about 99.9% of them need a kidney. And without a healthy kidney, these patients they tend to live on average about 5 years if they need dialysis. So dialysis is basically a process of cleaning your blood. So a dialysis machine will replace your broken kidney, and a patient will have to go about 2 or 3 times a week to get all the blood in their body clean and changed in order for them to be healthy. But as you can imagine, changing all the blood in their body and cleaning all the blood will take a lot of time, and it's also really tiring. So if you're on dialysis, you find that you cannot do a lot of things, you're constantly tired, and your quality of life just decreases by a lot. And the process of getting a kidney takes a long time, and some people are not lucky enough to get a kidney donor. So the process right now is that they either have to depend on their friends or family to donate them a kidney, or they go on the organ donation waiting list, where they're essentially waiting for someone to die of a car crash or a heart attack. And if this organ donor suddenly dies, they have to hope that they get to the hospital in time so that they can save their organs. So you just have to be really lucky. But bioprinting has the potential to change all this, right? So what if we could just harvest some cells from this kidney patient and turn them into a fully functioning kidney? And even better, what if we could print the kidney in 3D for someone and then transplant it into their body? And that way we know definitely the kidney will be compatible with their body. So bioprinting is trying to turn this vision of printing organs into reality. Okay, but at the moment, we're still decades away. At the moment, it's only possible to print a layer of tissue about 1 cm thick. But to fully print and to print a fully functioning organ, we need blood vessels, we need to think of ways to deliver oxygen and nutrients to cells, and we also need to think about how are we going to convince all these stem cells to turn into a kidney. It's a huge problem, and we need people thinking about it. We need people engineering solutions. And so it's really clear that we need more people to come into this field and develop this new technology. We need scientists, we need engineers to create and implement innovative solutions. And the thing is, all of you watching right now can play a part in saving the world and changing people's lives by pursuing a career in STEM. And if you found any of the things I was talking about interesting or intriguing, you want to learn more, I 100% encourage you to Google it up, watch TED videos, go on YouTube, learn about all these techniques. And really, the first step right now is to study science, take an interest in STEM, and think about pursuing a career in STEM. Okay, so now that you have a good idea about what tissue culture is, its applications, and the potential career paths, let's let's test your knowledge and learn at the same time. So take out your phones and log into Kahoot and type the code that is displayed on the screen now. Hold on. So the code is 4989271. We'll just wait a little while for everyone to get their phones out. So it's better if you have two screens. So one screen to watch the live stream and another screen to interact with the Kahoot. No people. Hey everyone! Hi aquatic rabbit, tropical seal, speedy ant, and shining raccoon! Smart llama! We'll just wait another 2 minutes so that everyone has lots of time to join the Kahoot. Okay, guys, I think that's all of you. So let's go ahead and start our Kahoot. Okay, so the first question is something we already talked about earlier. How is meat unsustainable? And which of the following is a negative impact of meat production? Give you guys some time to answer. Yay! Okay, I'm so glad most of you got that correct. Okay, um, this is the scoreboard. Okay, so now this next question will be about climate change. And I wanted to introduce this thing called the Paris Agreement. So maybe you haven't heard of it, or maybe you have. But basically, in 2015, 195 countries came together and they promised each other that they were going to combat climate change together. So each country has pledged to try their very best to limit their emissions, and also have promised to help each other out by sharing technology and expertise with each other to help reduce global emissions. So the next question will be about the central goal of this agreement. So the question is, the Paris Agreement's central aim is to keep global warming below blank degrees Celsius. Okay, yes. So the correct answer is 2, but I see a lot of you also answered 1.5, which is very interesting because the actual goal is the central aim is to keep global warming 2 degrees below 2 degrees above pre-industrial level. So um, only so the goal is to um, limit the temperature of the earth about 2 degrees from when about 1850 to 1900, that period. But really, it'll be much better. It's also stated in the agreement that it's much better if they could limit it to 1.5. So 1.5 is semi-correct, but 2 degrees is the most correct answer in this case. And this is the scoreboard. Congratulations, Flying Glider. Okay, so these next two questions are going to be about tissue culture. And the first question is, which of the following is not an application of tissue culture techniques? Is not an application. Okay. Okay, so we have a range of answers here, but most of you did get it correct. Um, okay, so I don't expect everyone here to have heard of this thing called muskin. So I've only recently heard about it myself. And the next slide, I'll explain what muskin is. Ooh, someone has knocked flying glider off her seat. Okay, so Muskin leather is actually a type of vegetable leather created from mushrooms. So it's a more environmentally friendly alternative to like killing and breeding animals actually, but it's not grown in a lab. It's farmed, so it's grown in like a big field of dead and decaying organisms. And actually, the mushroom roots is what grows and becomes this rubbery material that can be used to replace leather. So search it up if you're interested. It's really interesting and it's currently being commercialized. And who knows, maybe in the future we'll see lots and lots more things made of mushroom leather. Okay, next question is what is a bioreactor? So if you've been tuning in to our Google Classroom, um, there's some it's on the list of vocabulary that I recommend people look up. Ooh, lots of answers flowing in. Okay. So another range of answers here. Okay, but most of you got it correct. So it's correct. A bioreactor is a machine used for growing organisms under controlled conditions. So it's basically a place where you'd put all your petri dishes with the cell culture, and the environment inside the bioreactor should encourage these cells to grow and divide and maybe slowly turn into tissues. So it is not a device used to control a nuclear reaction. That would be a nuclear reactor, and it doesn't heat up your food or generate electricity. Okay. Congratulations, tropical seal. Okay. These next two questions will be about stem cells. First question is, what is a stem cell? Again, if you've been tuning into our Google Classroom, you'll probably find this really easy. Ooh, has everyone answered? Okay, 1 second left. All right. Okay, we have a range of answers here. I see, but not everyone got the correct answer. In fact, most of you answered a cell that can produce all types of cell types of the body. Okay, that's also technically correct, but not the best answer in this case. So a stem cell is a cell that can make copies of itself and more specialized types of cells. Okay, so the green and the red answer is both correct, but the red answer is more correct. So a cell that helps to fight against infections, that would be a white blood cell. That's not a stem cell. A cell that is specialized, not necessarily. That's not what we're referring to when we're talking about stem cells. So the correct answer is a cell that can make copies of itself and more specialized types of cells. This next question is also be related to stem cells. Congratulations, tropical seal. Okay, so where can scientists obtain stem cells? Okay. Ah. Okay. So I see most of you got that correct. So indeed, you can obtain stem cells from both an embryo and also other tissues within the body. Um, and fun fact, stem cells harvested from embryos are called embryonic stem cells, and they divide really easily. But the challenge of embryonic stem cells is convincing them to turn into more specialized cells. Okay, I see we have a tight race to the top. Guys, don't be discouraged. You can still win if you answer faster than everyone else. You get more points if you answer faster. Okay, so which of the following is a major obstacle in the development of lab grown meat? Okay, this is a bit tricky, but read the question all the way and I'm sure you'll get it right. One more answer. Okay, we have a range of answers, but most of you got it right. So the correct answer is all of the above. So let me explain. So when scientists are culturing meat in a lab, there's lots of different obstacles, more than what is listed here. But like in a nutshell, they first have to figure out what is the best solution to grow all this cultured meat in. What is the best sort of solution so that these cells will be happy and they'll propagate and turn into tissues. So they have to figure that out, figure out the best culture medium to grow the cells in, and they also have to figure out what kind of structure they will grow the cells on. So this structure is called a scaffold, and the scientists have to figure out what's the best material to make this scaffold, and also if they want cultured meat to be widely accepted and popular, they need to make lab grown meat taste the same as real meat. So this is much harder than it might first much harder than it sounds. So they scientists technically need to grow fat, they need to grow cartilage, blood vessels to recreate the flavor and texture of real meat. Otherwise, it just wouldn't taste the same and it wouldn't be popular. So there's all these challenges that come with culturing meat. Whoa. Okay, I see people that haven't been on the leaderboard are on the rise. Okay, these next few questions will be about bioprinting. Two questions. So, bioprinting is a technique that deposits layers of material, blank slices at a time. So, if you're familiar with 3D printing, this should be a really easy question. Okay, one more person. Okay, the correct answer is one slice at a time. So the way 3D printing works, well, let's talk about 3D printing now, is that it slices your object into these tiny layers, and the printer will actually print one layer at a time. And the same concept is used for bioprinting. So it will slice, let's say, an organ or a piece of tissue like a meniscus into lots of little tiny layers, and it will print every layer one slowly. So just one slice or layer at a time. But of course, the difference between bioprinting and 3D printing is the filament. So in bioprinting, you use cells, and in 3D printing, traditional 3D printing, you use plastic. Okay, one of the most difficult challenges in bioprinting is how to supply blank to all cells in a full-sized organ. And remember, the faster you answer, the more points you get. So you have a chance to knock the lead out of the leaderboard. And there will be 2 winners today, so it's not just one person getting a prize. Okay, 2 more people. Zero. Okay, so the correct answer is oxygen and nutrients. So a hydrogel is not the correct answer. A hydrogel is sometimes used as a scaffold, or it's part of the material they use for bioprinting, but it's not something that the cells need to survive. So the correct answer is oxygen and nutrients. And we've mentioned this a few times, that one of the big challenges is how to print connective tissue so that all these cells will survive. Okay, I see some movement in the leaderboard. Okay, so this question is all about biomedical engineering, and I think it is the last question for today. Which of the following is not what a biomedical engineer is trained to do? So if you've been following our Instagram and Facebook pages, on Thursday we posted something, a graphic on biomedical engineering, what it's all about. So if you get this wrong, do go have a look at it. Okay, so the correct answer is treating sick patients in a hospital. So, a biomedical engineer is an engineer who specializes in the human body and biological processes. So, even though a biomedical engineer does things that are related to the medical field, they are not technically doctors. So, a doctor is someone who is trained to treat patients, but a biomedical engineer is someone who spends his time or her time developing hardware and tools for doctors to use to treat patients. Okay, so that was the last question, and congratulations, Tropical Seal and Smart Llama. We will be, but stay tuned, guys, to the next last question. So this next question will not be marked, and everyone's gonna get it wrong, so it's not graded. But remember the answer that you put to this next question, as we will be asking for your answer if you want to claim your prize. So just remember what you've answered to this next question. If you could name a planet, what would you name it? Would you name it after yourself? After your favorite food? After your favorite TV show? Country? Okay, please remember what answer you put down to this question if you want to claim your prize. Okay, guys, thank you very much for answering. Cool. Congratulations to all the winners. I really hope that you had fun. And I really hope that even if you didn't win, you had fun and you learned something today in this 1 hour. Okay. So now. Congratulations, Tropical Seal and Smart Llama. Please contact the Penang Science Cluster via the link that will be posted shortly in the comment section, or email us your name or your username that you use for Kahoot. Get in contact and we'll send you your prize as soon as possible. Thank you everyone for tuning in. This live stream will be uploaded onto our Facebook page, so you can revisit it at any time. Our Kahoot will also be in our Google Classroom, so you can play it again, test your knowledge, have fun with it. And next week, we will be learning about electromagnetism. So there'll be whole new classroom resources that you can access starting tomorrow on Monday at 10 a.m. And we hope that you'll enjoy, and there'll also be a live stream next week Sunday at the same time on our Facebook page. So tune in, and I'm sure it'll be really fun, and you'll also have another chance to win some prizes. Thank you for joining, everyone. I hope you had fun. I had fun.